Now we're going to look at finding equations of lines. So in the last lesson we were kind of graphing and looking at some of the characteristics of particular kinds of lines. Now we're going to use those ideas and write our own equations. So the first thing we're going to point out is the point-slope form of a line is written y minus y sub 1 equals m times the quantity x minus x sub 1. Two lines with different y-intercepts are parallel if they have the same slope. It's important to say different y-intercepts because if they were the same y-intercept, they'd be the same line. So the different y-intercept, same slope are parallel lines. Two lines are perpendicular if the product of their slopes is -1 or if their slopes are negative reciprocals of one another. The equation y equals mx plus b is in slope-intercept form. The graph of an equation y equals mx plus b has slope m, and the graph of an equation y equals mx plus b has y-intercept of 0b. So the first few problems we're going to look at, it says find the equation of the line having the given slope and y-intercept. In other words, they want an equation in slope-intercept form, which we can give them if we have an m and if we have a y-intercept. So since I'm given a slope, that's always m, and I'm given a y-intercept, that is always b, this makes it very easy to write an equation in slope-intercept form if they give us the right information. So it's mx, so negative 15x, plus my y-intercept, which is 12. So there's my equation. They gave me a slope, they gave me a y-intercept, I just plug it into the proper form. The next one, y equals, my slope is 2.7 x, and then my intercept is negative 4.3, so minus 4.3. So what happens if they don't give me the y-intercept, if they just give me some random point? Well, there are a couple different ways that we can tackle this problem, so let's look at number 12. Now, the very first thing in our key terms was something called point-slope form. Point-slope form is y minus y1 equals m times x minus x1. So we have slope-intercept form. This is point-slope form, meaning if we have just a random point, it doesn't have to be the intercept, it can, but it doesn't have to be, it can be any point and a slope, then we can use this format. For slope-intercept form, it has to be the y-intercept. So this format can be any point, which makes it useful if we're not given the intercept. So the way we use this form is it's y minus my y-coordinate equals my slope times the x minus my x-coordinate. So if we're going to write an equation in slope-intercept form, we can't start there. We have to start with what we're given, and we're given a point and a slope, so we've got to start with point-slope form. And now I can manipulate it into slope-intercept form. So in order to do that, I would have to distribute my parentheses. So 2/3 times x is 2/3 x, and 2/3 times 1 is 2/3. And then I would add 6 to both sides to get y by itself, which is going to give me y equals 2/3 x, and then a negative 2/3 plus 6 is plus 16/3. Or it's going to be 5 1/3. So if you subtract, if you put it in your calculator, you can just get an improper fraction, or you can have a proper fraction. It doesn't matter which one. So here would be our slope-intercept equation. So if the problem asks you for an equation of a line, they might specify in slope-intercept form. Most of the time we work with equations in slope-intercept form, but we use the point-slope form to get us started. So remember, it's y minus the y coordinate equals m times x minus the x coordinate. Notice when I plug them in, I still have an x and a y in my form. And just like in slope-intercept form, there's an x and a y. We only replace the m and the b. So here we replace everything except the x and the y, because that x and y represent every single possible ordered pair on the line if we were to graph it. So this problem, we were given a point and a slope. What happens if they don't give you slope at all and they give you 2 points? So here's a couple problems where we're given 2 points and the directions are the same. We still have to find an equation. Well, the first thing I'm going to have to do is find a slope, because we definitely need that. Whether we're using point slope or slope intercept, they both contain the word slope. They both have slope. We need slope. So I'm going to have to find the slope. And remember, that formula is you subtract your y's on the top and you subtract your x's on the bottom. So my y's are 10 and 8, so if I go 10 minus 8, then I have to go 1 minus 3. So that's going to give me 2 over negative 2, which gives me negative 1. So now I have 3 pieces of information. I have 2 points, and now I have a slope of negative 1. So I'm going to use my slope, and I'm going to pick one of my points. It doesn't matter which one. And I'm going to go through the same process I went through a minute ago. I'm going to use my point slope form. So y minus, which is 8, times my slope, x minus my x coordinate. So distribute my negative 1, that gives me negative x plus 3. Move my minus 8, and that gives me y equals negative x plus 11. So there is my new equation that goes through both of these points, 3, 8, and 1, 10, and has a slope of negative 1. Now, here's another twist. What if they don't give you a slope at all, and they don't give you 2 points? How do you find a slope? So this says, write an equation of the line containing the given point and parallel to the given line. Parallel, key word. So they give us an equation of, which is 4x minus y equals 8. So since my new equation is going to be parallel to this one, if I find the slope of this one, then that's going to be the slope of my new line as well. So I need to find the slope. So I've got to get it into slope-intercept form. Looks like I have to divide everything by negative 1. So y equals 4x minus 8. Now remember, this is not my new equation. This is just rewriting the equation they gave me. All I need from this equation is the slope, because I know that my new line is going to be parallel to this line. So that's all I need. So now I have a slope of m equals 4, and I have a point of 2, negative 1. So these are the 2 pieces of information I'm going to use to write my brand new equation. So y minus y1 equals m times x minus x1. So y minus my y coordinate, which is negative 1, equals my slope of 4 times x minus my x coordinate. So this is y plus 1, and when I distribute, I get 4x minus 8. Get the y by itself. So I have 4x minus 9. So y equals 4x minus 9. That is my new equation that is parallel to the equation that they gave me, and it goes through the point 2, 1, if I were to graph it. If they wanted me to find a perpendicular line, then I wouldn't have used the slope 4. I would have used the negative reciprocal, which would have been negative 1/4. So the next problem, that's exactly what they're asking me to do. They want me to find an equation that's perpendicular. So we're not going to do both of these. Let's do 22. Again, I have to find a slope, so I'm going to use the equation that they gave me, which is 5x plus 10y equals 2. Let's figure out the slope. So I'm going to put it in slope-intercept form. So 10y equals negative 5x plus 2. Divide everything by 10. That's going to give me y equals negative 5 over 10 is negative 1/2 x, and 2 over 10 is 1/5. Again, remember, this is not my final answer. This is just the equation that they gave me rewritten, and all I need from it is my slope. So I've got a slope of negative 1/2, and since I need a perpendicular line, I need the negative reciprocal. So the negative reciprocal, so we flip it and opposite it, so that's going to give me a slope of positive 2. So I'm going to use slope of 2 and my point, negative 3/6, to write a brand new equation. So y minus y1 equals m times x minus x1. So y minus my y coordinate is going to equal my slope of 2 times x minus negative 3, so it's going to end up being plus 3, because minus a negative. So distribute, and finally isolate the y. So y equals 2x plus 12. So my new equation is y equals 2x plus 12. This is perpendicular to the line they gave me of 5x plus 10y equals 2, and it goes through the point negative 3, 6.